All right, here we go. This is section 7.1, the start of the measurement of angles. And we're going to be learning about something called a radian. And this is all going to be built off of, let's start with just a circle, a very ugly circle. Um, Now, if you can think back to your time in geometry, we had, there's the center of our circle, and uh, this is going to be the radius of the circle. And when we had a central angle, so an angle coming out from the center. Now, obviously, this other piece over here is also radius and length, but it intersects an arc. And so this is a central angle. Up here we have S. This is going to be our arc length. So R is radius length of the radius, and S here is going to be our arc length. You can think about it, if I took a piece of string and kind of laid it around the outside of this circle, there along just the arc, how long is that going to be? And that's what an arc length is that length, and it's curved. It's the edge of the circle there, but that has a specific length. You can measure it kind of with a piece of string, for example. So we have the number of radius units in the length of an arc, AB, and if we kind of think through, well, hey, if this is a radius right here, and we know what the length all the way around a circle is, that's the circumference, right? And circumference is equal to 2 times pi times r. And so this whole length all the way around is 2 pi r. Now that's going to be important for us because we can measure the angle, not just here inside from the central angle, but we can also have the angle of an arc. And the measure of a central angle and its intercepted arc, it's the same. Those are equal measures. And we're very used to measuring them in, for example, in degrees, that the entire way around a circle is 360 degrees. But we're going to start using radians, and radians is going to be, it doesn't have its own specific unit, no notation for it, like the degree in degrees. But we'll talk about it in terms of, well, it kind of in terms of its length, so that if 360 degrees all the way around, that is going to be equal to, well, what's the length there? That's 2 pi r, so that's equal to 2 pi radians. That the entire measure around of the circle is 2 pi radians. And again, this is just it's a measure of the angle, so whether or not the radius is 5, 10, 100, whatever it is, the measure around wouldn't change. Now the circumference certainly would, because that's length, but whether or not the circle is bigger or smaller doesn't change the angle. For example, the angle of that blue portion right here and here. All right, so to find the number of radians in one revolution of a circle, one revolution in degrees is 360 degrees, and one revolution in radians is, oops, that's an ugly 2, is 2 pi. That's the measure of the angle all the way around. It's 2 pi. And so let's now this one other part I didn't mention here is that the angle that we're talking about, whatever angle that is, that's commonly referred to as theta. And so it looks like theta there. Let's write that a little bit better. Theta. And that is going to be equal to, again, the arc length, so S, divided by the radius. Remember, we don't have radius here. It's, if you're thinking of the entire circle, it's the entire circumference divided by the radius. That is the measure, the angle measure in radians. All right, and we'll play this out a little bit more as we go. And this again was called theta, and you'll hear that used quite a bit as we go along. All right, hope that helps.